All right, our objective for today is that I will be able to factor perfect square trinomials and the difference of two squares. All right, so these are kind of special case trinomials, and if you can remember these rules, again, it'll make it a lot easier to factor for you. So, just to go back to what we learned a little bit ago, a few lessons ago, you can factor some trinomials by reversing the rules for multiplying special case binomials. So if you remember, we learned that if we have a plus b squared, all right, it becomes a squared plus 2ab plus b squared. And a minus b squared becomes a minus b times a minus b, which is a squared minus 2ab plus b squared. So again, this is going to really help you for going backwards. So if you write these down, that'd be great. All right, a couple ways to recognize a perfect square trinomial. So a perfect square trinomial always has the first and last terms are perfect squares. All right, so like if the first term is 9 and the last term is 25, those are perfect squares. The middle term is twice the product of one factor from the first term and one factor from the last term. So that might be a little hard to understand, but as we continue with this, it'll make more sense. So first problem, factoring a perfect square trinomial. So if we go back to that rule, we know that when we have a squared minus 2ab plus b squared, okay, that turns into a minus b squared. All right, so all we got to do is take the square root of a and the square root of b, the square root of the last term, and you will get this. So 1 is a perfect square, all right, 36 is a perfect square, and 12 is 2 times a factor of 36, which is 6. So we take the square root of 1, which is 1. So our first term is just going to be x. All right. The square root of x squared is x. And then we take the square root of 36, which is 6. And because this is a minus here, we go x minus 6 squared. And that is the answer. Like, that is how easy it becomes. You can do all the other stuff if you want to. You can write 36. You can write negative 12. All right. And you can say, okay, that's going to be negative 6 and negative 6. All right. And do all that. But this just makes it easier. So take your pick. You can choose if you want to take the shortcut or if you want to do the x. Alright, I want you to try this one. I want you to pause the video and try it and then check your answers. Notice it's not very much different from the last one. Alright, so on this one, what you should have had is x plus 6 squared. So now that this term is positive, alright, when we have a squared plus 2ab plus b squared, that turns into a plus b squared. Alright, so that is why you have the shortcut. Makes it a lot easier. Alright, so when a is a number other than 1, it's still the same process, it's just a little bit different. So now we're still going to do the same thing. We're going to take the square root of the first term and the square root of the second term. So the square root of the first term is 2x, and the square root of the last term is 5, and this is positive, so 2x plus 5 squared. Okay, and I know that this is a perfect one that I can use for a special case because 4 is a perfect square, 25 is a perfect square, and 20 is 2 times a multiple of 4, which is, or a common, greatest common factor of 4, which is 2. Like, 20 is a multiple, is 2 times 2 times 5. Alright, so that's why it's a perfect square. Alright, again, I want you to pause the video and try this one, and then check your answer. Alright, so your answer should have been 4m minus 9 squared. Again, I took the square root of 16m squared, which is 4m, and the square root of 9, which is, or 81, which is 9, and then the middle term's negative, so that's going to be negative as well. Alright, so let's go back to this rule. So a plus b times a minus b gives you a squared minus b squared without a term in the middle. So again, a and b have to be perfect squares. So for example, when I'm given this one, z squared minus 9, there is no term in the middle with just a z. So I know that my factors have to be something minus something and something plus something. Alright? And I also know that these are perfect squares. 1 is a perfect, z squared is a perfect square, and 9 is a perfect square. So the square root of z squared is z. The square root of 9 is 3. So this becomes z minus 3 and z plus 3. Again, you can use your x. You can say, what are my factors of negative 9 that add up to 0? Because technically that's, I could add in a 0 there, and it would be negative 3 and positive 3. Right? And you would still get the same answer I just got. Pause the video and email me that you are at 7.6 seconds. 7 minutes and 6 seconds. Alright, I want you to try both of these because they're both perfect squares. Alright, pause the video and check back in with me in a second. Alright, so you should have had v minus 10 and v plus 10, and then k minus 4 and k plus 4. Alright, this works the exact same way as what we just did, but now there's just a number in front of the x squared term. So I'm going to take the square root of both of them. The first one, 16x squared, is 4x, plus 81 squared is 9, and then 4x minus 9. Okay, it does not make a difference. There's just a number in front of x now. Alright, so I want you to try this one, and then I want you to think about this question. Pause the video and do it. Okay, so you should have had 5d minus 8 and 5d plus 8. And then the question down here says, could I do this with 25d squared plus 64? Alright, it contains two perfect squares, so can I use the method above? You should have thought to yourself, no, this is like, this right here is called the difference of squares, which difference means subtraction. So it only works when you have a minus sign in the middle. When you have a plus sign, nothing's going to it's not going to work because it's just not. That's not how it works. All right. All right, last thing. So if you're looking at this one right now, you should be able to really easily see that this doesn't have any special case as of now. All right, so what we need to do is factor out a common factor just like we did yesterday. All right, so common factor between 24 and 6 is going to be 6. So I'm going to factor out a 6, and that leaves me with 4g squared minus 1. All right, now I have a difference of squares. I have 4 and 1. So the square root of 4g squared is 2g. The square root of 1 is 1. So 2g minus 1 and 2g plus 1. Okay, again, these will come to you as you do them more often. It's not difficult, it's just a matter of you remembering all the rules. Alright, lastly, I want you to do these 2 examples. Alright, so for the first one, you should have factored out a 12 and gotten 12 times t squared minus 4. And then, I did that wrong. Oops. And then when you factor it completely, you get 12 times t minus 2 and times t plus 2. And then the second one, you should have factored out a 3, and you're left with 4x squared plus 4 plus 1. And this is what we did at the beginning of the lesson. So now we have 3 times 2x plus 1. So I took the square root of 4x squared and the square root of 1, put it in here, and then squared it. Alright, that is the end of the lesson. You need to go and you need to do the homework. You are going to have a quiz tomorrow. I mean, not tomorrow. You are going to have a quiz Friday, alright, on all of this in order to check your understanding.